My name is Morten, and here in northern Sweden at 63 degrees north, I'm currently upgrading my remote-controlled imaging setup in the observatory. The brain of the entire operation. A Beelink SER3 miniature PC running N.I.N.A, connecting everything through ASCOM drivers and powered on and off through a Homey smart home system and Z-wave relays. Today I'm going to show you the complete setup from the BIOS setting to the moment you click Start Sequence. Every driver, every setting, every cable, let's build it. So why go with the PC solution to start with? There are so many versatile and small options available. Well, personally, I don't like to be restricted to an ecosystem of products. I want to be able to pick and choose however I want. And although there are solutions out there today that might let you do that, I have grown accustomed to the versatility and in all the ways you can configure and use the PC. I used to have a laptop and a very long USB cable when I first started out in this hobby. But that was before the observatory was built, and the MiniPC today is just space-saving and energy-saving options. And you could as well go with a full-size PC if you want. If you're going to put the PC on the telescope, well, then the MiniPC is a must due to the fact that you want to keep the weight down. For me, I'm going to place it in a compartment just at the base of the pier in the floor of my observatory. I also want to have something DC powered, not relying on batteries, as we get very cold winters here in Sweden. It can be below -30 degrees Celsius. Finally, I don't want wireless, even though I have a very robust and fast wireless network with ubiquity access points, just to be 100% sure that everything works and I have excellent speed. I can configure the MiniPC to power on automatically when the power is restored. Combine that with a remote-controlled relay and you have full control over power cycling. More on that in a moment. The Beelink SER3 specifically, AMD Ryzen 3 3200, 16 GB of RAM, 500 GB of SD NVMe solid-state drive, 4 USB 3 ports and gigabit Ethernet. My last MiniPC was also a Beelink, and it survived and performed without any issues several harsh winters in the observatory. I'm not sponsored by Beelink in any way. This is just what I choose after researching what runs N.I.N.A reliably without breaking the bank. With all of the upgrades that I'm doing to the observatory for the upcoming season, it's also time to upgrade the Beelink MiniPC that I've been having in there since I first built the observatory back in 2022. First of all, I want the latest version of Windows. Second of all, I want to have a little bit more speed and power. Now, this is the Beelink MiniPC Model SER. This computer is an AMD Ryzen 3 16 GB of memory, 500 GB of solid-state storage, and the usual connectivity ports. I will be running this PC on a wired LAN since I have gigabit LAN out to my observatory. I don't want to run any wireless applications whatsoever. And I'm going to take you through the installation and configuration of this mini PC, including all of the drivers and software needed to operate my automated home observatory. Let's take a look to see what is in the box. A small user manual, some accessories here in the form of cables. This is a mounting bracket should you need to use that. We have an HDMI cable if you're connecting this to a monitor. I won't actually connect anything to this when it is outside in the observatory, apart from power and the USB cable. And I have a small power supply here. I'm actually going to use Wake on Power if that is available in the BIOS. In my old mini PC I used Wake on LAN. That also worked, but in case of a power failure, that feature actually requires you to go out and manually start it, which is a bit annoying because the power goes out here once in a while. We are at 63 degrees north. The actual mini PC then. Plastic removed. The PC itself is very lightweight, I would say. This is not a fanless PC, but my older model wasn't fanless, and that has been working flawlessly, I would say, out in the observatory, even though in conditions of -20 or 30 degrees. On the front of the mini PC here, we have power on, speaker, and 2 USB connections. And on the back side, we have the power, 2 HDMI outputs, 2 USB 3 outputs, and 1 Ethernet output. On the bottom side, we appear to have some rubber feet that will keep it from moving if you're using it on a desktop, for example. I don't really care in the observatory, but here you have the mounting holes for the bracket if you're going to use that. It is a BIOS for which you press delete to enter the setup, or F7 for boot options. Other than that, there's no revolutionary things about this, apart from the fact that it is a miniature PC. And I will hook this up now and install the operating system, and then we will dive into some configuration of Windows and N.I.N.A to get it ready for the observatory and my new equipment. With the Windows booted, there are a few things to configure before we install any Astro drivers or software. These aren't optional if you want a reliable, unattended operation. First thing, go to Power Settings and Power Options and select High Performance Plan. Disable any screensavers or sleep modes to make sure that your mini PC is always reachable. Second, disable Windows Update from restarting your PC automatically. Go to Settings, Windows Update, Advanced Options, and set your active hours to cover the entire imaging window with a big enough buffer before and after. Nothing ruins a clear night like Windows deciding to restart the PC at 2 AM in the morning. Third, enable remote desktop solution. I personally use Chrome Remote Desktop connected to my Google account, and that will let me connect to the Mini PC from wherever I am in the world. You can install that by searching for Chrome Remote Desktop, run the small installation and configure the PC for remote control. Here we are in Windows on the newly installed Observatory PC. That is the Beelink SER with the AMD 3 Ryzen processor, 16 GB of RAM, 500 GB of solid-state storage. This will be a sufficient enough computer to run my observatory systems. I don't want to bore you with the complete Windows installation, but this has been completed, obviously, and I've run through all of the updates. I've also disabled or uninstalled all unnecessary applications and services that I don't need on this PC, including the Wi-Fi, since I'm using a cabled Ethernet connection for connectivity and internet. You also want to check on your power saving settings to make sure that the machine does not power down or anything like that. The other thing I want to do is to enable automatic power on. On the old PC I used Wake on LAN, but that had a limitation, and that was in the event of power failure. Power on LAN does not work and you manually have to power the machine on for the first time, and that can be a bit annoying. So this time I want to use the auto power on with AC power loss. And in order to do that on this PC, I found this tutorial online just to show you the way to find the setting in the BIOS. That can be a little bit tricky. Now, to enter BIOS on the Beelink, you press the delete key. Make sure you do that several times right after starting the PC. It should look something like this. If you have another PC, that can differ, of course, but you want to scroll to the Advanced tab in the AMI BIOS, and you want to scroll down until you reach the AMD CBS setting. Select that, and you want to select the FCH Common Options. I know this is not straightforward. It took me a while to find it in BIOS the first time without Googling for it. And when you have arrived in there, you have the AC power loss options, and you will set this to always on. And that means if the computer loses power, it will automatically power on. And that can be exploited with the use of a power relay, a power button, preferably something that you can remotely control then, so you don't have to physically push a button, that is. I use a Homey smart home automation system with Z-wave relays to control lights, switches and other things in my house. I don't have the Z-wave relays out in the observatory. Remember, I didn't want any wireless solutions out there. I have them in my house, in the electrical fuse box, and inside I have a very large Z-wave antenna controlling the home automation. I personally use Fibaro's Z-wave relays, but other brands are also available. If you want, you can also use Zigbee relays, but stay away from the 433 MHz. They are not encrypted and not as safe to use. In the observatory, I have a few outlets, and those are controlled with these relays. I also have other relays controlling the heater and fan and the motor for the roll-off roof. When this goes live later on, when I have received all of my gear and connected everything, I will use this that is called Telescope Observatory right now. This is a power outlet in the observatory, and that is controlled through the relay. I can turn it on and off. And with that, I will turn on the mount, accessories, and the PC. But right now, when testing this, I have another plug-in Z-wave relay that I have inside the house actually, although it's in the observatory here in Homey. Now with this, I can turn the outlet in which the PC is plugged in on and off. So if I turn the PC off in Windows now, and then I turn off the Z-wave relay, I can then turn it on, and that will trigger the computer to start, enabling me to, whenever I want, turn the PC on, even though it's off and even though the power has been broken to it. So I will make use of this to turn on all the equipment and to start the PC in the observatory without actually physically triggering any buttons or going out to the observatory. I'm not going to go deeper into the home automation system in this video, but if you're interested or have any questions, drop me a comment below and I will get back to you on that. Since this is a completely fresh install of Windows, I don't have any applications or drivers whatsoever to control my observatory equipment. And I want to start with the basics here, so I have a folder here for drivers. This is, of course, a list of drivers needed for my equipment. Yours could vary a little bit, but you probably already know that. We're starting with the ASCOM platform here. We're going to be downloading the latest version, 7.1.3. And when that is complete, you want to double click on that file, and we are going to install the platform. Now I will go through this step by step with you, but if you don't want to do that, you can simply skip ahead to the part in this video that you want to watch. Now I'm not going to change any settings on the platform. I'm simply going to click install. And we are going to be waiting for the installer to finish. When the installation is complete, you should see this, and you should also have some icons on the desktop. We will just click finish there. And then I'm going back to the browser here. And let's see what's next on the list. I have some drivers from MLastro. Now, when recording this video, I haven't actually received my mount yet. I'm in queue to get the one of the first 50 MLastro 1. And what is actually necessary for that? Well, I need the USB driver and I need the OnStep X ASCOM driver. The MLastro hub is optional. We can download that to install it, but first we will start with the USB driver. And this is the universal Windows driver here. And I will also download the OnStep X. These are linked from MLastro website, so you don't actually have to look for them. So download. And for the OnStep, I've noticed that the security measures in Windows is a bit tight, and it's a warning for that, but just disregard and save it anyway. And when opening up the downloads folder here, we can see that we have some new folders. So I'm going to extract the driver here, and I'm going to extract OnStep X also. You could put them anywhere. I'm probably going to delete everything in this folder later, so I'm just putting it here, but in separate folders for now. Now, starting with the universal Windows driver here, it has no installation software. You can do it two ways. You can plug in the mount, but I don't have that right now. And when asked for driver, you can point to this directory, or we can manually tell Windows to install this driver by right-clicking the setup information file here and choosing install, and that will install the driver on the system, and it will automatically detect the driver once you connect it. So that is done. I will keep that file on the machine for now just to be sure. Then we're moving on to the OnStep X, and here you have a setup file. It is complaining that this file is unrecognized, but you will click run anyway, and the installation should start. Accept the agreement, click next, and then simply install. And that should take care of the installation. Once the driver is finished, click finish, and that's completed, and I can delete those files. I will not need them. I'm gonna save the MLastro hub setup for now, since it is probably going to change before I get the mount delivered to me, and I don't want to go through the hassle of replacing or upgrading right now, so hold off with that. Moving on to the next, I also have some hardware from Pegasus Astro. They used to have individual drivers in the past. Now they have a Unity platform that include all of their products. Good or bad, yes or no? I think it's good maybe not to have too many software to keep updated, and it's nice to have an installation. So just double click and click install when you're prompted for the Unity 3 platform. It will proceed with installing. Well, right now I have the Flatmaster 150, and I'm looking into maybe getting the Flatmaster Neo 120 that I can attach to the telescope directly, but we will see. When it's finished, it will open up the Unity 3. I don't have anything connected right now, so I can't do anything here, but to close it, I'm also going to be using N.I.N.A, so I will select and control the equipment in there, so I won't be needing this. Let's remove that. Also keep it tidy here in the download folder. And what's next? I have some Player One astronomy gear, and Here you want to install the native camera driver if you're using Windows like I'm doing here. So I'm going to click download on that. That driver will take care of all Player 1 camera models. Then I'm going to scroll down to ASCOM drivers. I'm actually not going to use the ASCOM camera driver, but it could be good to have it installed anyway, just in case I want to use that in some software that can't use the native driver. And I also want to have the filter wheel ASCOM driver. I'm downloading that as well. Switching over to my download folder, I'm going to extract the camera driver. I'm going to extract the other two drivers for ASCOM, and that is the camera ASCOM driver and the filter wheel ASCOM driver. And those will all be installed. Starting with the native camera driver, I'm just simply double-clicking the application here and click install, and that should take care of itself. Just want to click that I actually want to install and trust the driver there, and then it finished quite quickly. Going back to the downloads here, and I'm going into the ASCOM camera driver, repeating the procedure and installing that on the PC. And finally, I'm going to install the ASCOM Player 1 filter wheel driver in the same manner as I did the ASCOM camera driver. Accepting the agreement, clicking install and letting the installation finish. Now those three are done. I can remove those so we won't be bothered with all of those files. And if I'm looking at my bookmarks of drivers here, I have installed the ASCOM platform completely. I've installed the drivers for the mount and the OnStep X controller. I have my Pegasus Astro unified platform, and I have my Player 1 Astronomy. The one thing I haven't mentioned now is that I have a ZWO EAF that I'm going to be using on my SQA106 telescope. That one can actually not be downloaded separately, and there is native support for that in N.I.N.A. So if you have a ZWO EAF and you're going to use N.I.N.A, you don't actually have to install any ZWO drivers whatsoever. But you're probably using a ZWO mount or a ZWO camera or filter wheel. In my case, I'm not using that at all, so I'm not downloading that. If you do, browse to the website and download that. I'm going to go over to imaging now, and I'm going to be downloading the latest version of N.I.N.A here. I also want to see or download the latest version of PhD2 guiding and select that for Windows, download. And I also have SharpCap. I really like SharpCap when doing planetary photography or when doing polar alignment, so I will be installing that as well. Switching over to my download folder, you can see that we have to extract N.I.N.A here, so I'm gonna do that, and when that is finished we are going to be executing the N.I.N.A setup bundle file. You simply accept the terms and then you click on install, and then we are going to be waiting for that installation to finish. Setup successfully completed. I'm going to click close here. I don't want to launch it right now. I will be removing the files, then I will be executing the PHD2 installation. All of these installations are pretty straightforward. There's not that many options, not during the installation phase anyway, so let's move on with the Sharp Cap installation. Now for this you're going to be needing a license that you can purchase for 1 year, or there is a lifetime option also if you have used it for a year. And that could be beneficial if you are using it continuously like I'm doing. For the Sharp Cap installation, it doesn't really give you any options whatsoever during the installation other than telling you that it is completed, and we are going to click on close. I can remove the installation files for those two because I'm finished with that as well. And we can close some tabs here, go back to my bookmarks, and there's one thing missing now, and that is a planetarium software. And I like to use Stellarium, so just be careful to choose the right version here. And that is the Windows 64-bit, Windows 10 or above. And that file could take a little bit to download. Not here, I have a fast connection or bandwidth here. When the file is downloaded, you just double click on it. And we install it for all users, even though this machine is not going to have any other users than me. Going through the default settings here and then let it install. There's obviously going to be a lot of configuration later that we are going to be coming to, partly for some drivers, partly for N.I.N.A, PHD2 and for Stellarium, of course, to get those working in the normal environment required by the observatory. But we will cover that later in the video. So when finished, simply click finish here, and that is the whole thing for this section. There are a few other things that we are going to be required to download, but we are going to do that later when we are coming to the relevant part. One, for example, is plate solving, but we're not going to do that right now. We have some icons here. You can sort them however you like. I like to have them here on the desktop and also on the taskbar. The taskbar right now is hidden, but I can take that out to see it all the time. And then we can place the icons down here if we want. We can start with the ASCOM, the Pegasus, the Profile Explorer, that could be removed. And I can have my Sharp Cap, N.I.N.A and Stellarium apps up here. If I want to have these on the taskbar, I can just click on this and then I will show a list. I don't really like the new look of the start menu here, but let's scroll down here and right click on N.I.N.A and pin that to taskbar, PhD2 guiding I might want to have on the taskbar there. And also I might want to have sharp cap on the taskbar there. And later on I will see if I want to have some software for the MLastro mount or not. And now I can move these about in ever which way I would like. So let's just keep them like that for now, and we're fine with that. Before doing anything else on this PC and a part of the general setup, I want to create a folder here that I want to name incoming. And in that folder I want to keep all of the incoming data that I gather, just to know exactly where those files are. We are going to cover the file naming later, but I want to have folders with dates, and then I will, after each session, move the folders here over the gigabit network that I have to my storage solution and to be used by my desktop computer inside to process the data. When the installation is completed so far, you can restart the computer to be sure that the drivers are active, and then we can continue with the next steps. It is time to do some general configuration and settings of N.I.N.A. Let's start in the main menu, Options, and then the General tab. In the top left corner you have your profiles. You can add a profile, you can have different profiles if you have different types of equipment, and you can also have different profiles with different settings that you can choose from when starting the application. Together with that, you can use Profile Chooser on Startup to be on or off. If you only have one profile, N.I.N.A will start with that profile from the beginning. And in the top right corner, you can name your profile, you can choose language, and some general settings like the font you want to use in the application. You also have an advanced tab that you can expand underneath the general settings, and that is the auto update source. Here you can choose if you want the nightly updates, the beta updates, or the release updates. I find the application to be very stable at the moment, and I'm going with the release auto update source. You can choose a log level and device polling interval and image save queue size. And that is 2 seconds for the device polling and 2 image save queue size as a default. You can increase this to allow the application to queue more than one image into the processing. This doesn't really affect us with exposure times that are very long, so I would just leave this at the default setting. You can see that I have hardware acceleration set to off. That is just due to the fact that I don't have a monitor attached to this computer. And if you don't and have hardware acceleration on, you can get some phenomenons like a white screen when you're starting N.I.N.A. So if you get that, set this to off if you're using a remote desktop and don't have a monitor attached. Next thing is to set your primary user interface color scheme, and there are some settings here. You can choose the light, for example, or you can have a custom color scheme, and there you can select the colors individually if you would like. Moving along to astrometry settings. This is where you are going to input your site latitude, longitude, and elevation. It is very important that you do so here in order to get the correct settings for your location. I'm just going to input the numbers here for my current location in latitude and longitude. You can probably get these in any popular GPS software on your phone, for example. It's not really necessary to set the parameters for observer, observatory, and site name, but it can be nice. If you have a custom horizon for your location, you can set the custom horizon file here, and that will enable a custom horizon in N.I.N.A for use in the sequencer, for example. If you haven't already done so, I will include a link for you to watch a separate video on how to create a custom horizon and set it in N.I.N.A as well as in Stellarium. The custom horizon file here contains a 360-degree view field and the altitude for each degree or checkpoint, and that way N.I.N.A knows what is accessible or not from the location. So simply point the file out and click open, and that will be used the next time you start N.I.N.A or in the sequencer. Now we're done with the General tab. We are moving along to Equipment, and this is where you make some settings to your equipment. Some basic settings there is, because you also have settings on each individual equipment later on. Starting with some camera settings, I have the Player One Poseidon M Pro, and that is a pixel size of 3.76 nanometers. The bit depth is 16 bits, and I will set the Bayer pattern to auto. I want to disable bit scaling because it is not relevant for my camera since I'm using 16 bits here. You could probably use this if your camera has like 10, 12 or 14 bits. I want the default settings for bulb mode and camera timeout, as well as the RAW converter. I can set names now for the telescope, so I'm actually using the ASCAR SQA106, and I'm waiting for the ML Astro 1 mount. And I can set a focal length here, and it is 509 millimeters, and it is 4.8 focal ratio. You can choose a settle time after the mount's loose. It is 5 seconds by default. I think I used to have 8 seconds here, but I will increase it to 6. You can also select location sync prompt, that is the default. And you can select coordinate sync and time sync. That is default on, and I will keep it on. I don't have any weather app right now, and I don't have any GNSS source, so I'm keeping those default. I don't have any filter wheel attached just yet. If I did, I would have all of my filters here, and I can select names for the different positions. I will do that later on when I'm configuring the equipment, when the equipment has been connected to N.I.N.A. I can select a planetarium, and since I have Stellarium installed, I will select Stellarium here, and then I will let the ASCOM Alpaca Discovery settings be default. Next tab is the autofocus tab. I will have a separate video on the ZWO EAF-N focus motor. I will quickly go through the settings that I have in here now, and that is 4 autofocus initial steps, the star HFR autofocus method, the trans and parabolic curve fitting, 5 attempts, use brightest star. It's set to 0 now. If you have problems here, you can select a number. Let's say use the 10 brightest star or not. Auto crop, binning, and threshold default settings 1.1 and 0.7. On the right side, you have autofocus step size. I'm using 40 right now for the EAF-N from ZWO. A default autofocus exposure time to 4 seconds. Maybe I will increase this with the narrowband. Maybe I will have 6 seconds here. I want to disable guiding during autofocus. I don't have a focuser settling time. Number of exposures per point is 1. Inner crop is 1. Backlash compensation method is overshoot, and backlash out is set to 75. And why that is going to be deeper explained in my autofocus video, exactly on how to come to that conclusion. Right now, I don't have any dome control. I manually control the roll-off roof on my observatory. But if you have an ASCOM enabled dome or roof control, this is where you would configure shutter coordination, for example. Next tab, imaging. You want to make some configuration on how to save your files. First of all, I want to use the EXIF format. Fits is decapitated, and I want to use the latest. I don't want any compression or checksum, and no byte shuffling. You can set a default directory on where to save your files. I usually don't want it to save into the documents folder. I want to be able to find it quickly, so I'm using an incoming folder directly on the C hard drive here, and I will simply select that folder. Next, we're going to build the folder structure and the file name structure for the images created. And I actually want to start with the date. I want to make folders with dates. So that means I'm going to be using the $date $. I don't want any other folders, so that means I want to remove this, I want my file name to start with image type, and that is a light frame. I want the next to be object, and that is target name, I think. This, if available, the target name that you're using. So $, target name $. I then want the filter name. And then I want the frame number. So right now I have the date as a catalog, type of frame, object, filter, frame number. Then I want the bin setting. And I also want to know that it is the bin setting, so I have to type in bin before the $, and then binning. And then I want the gain. I'm just going to type in the AG for gain, and then gain. Maybe I will type in just a B for binning instead of bin, because that will look better. So B, and then G for gain. And then maybe I want the offset. I also want an O before offset, so I know it is the offset. I think I want to remove the S from the gain because it will look better. I would like exposure time. And I want an S after that for seconds. I also want the focus position. And I want to know that it is the focus position, so I'm setting FP before that. I also want an E before exposure. And I want the temperature. And a C. So that means I have the date as a folder. Then I have light, type of frame. I have the object name. I have the filter. I have the frame number, bin, gain, offset, exposure, focus point, and temperature. Now the reason I want all of this data in the file name is that I want to be completely sure that I apply the correct calibration frames, and it is also good to have this information because when I gather up light frames from different sessions, it could be hard to differentiate between them if you don't have stuff like focus position and temperature, because those two will make it unique, I would say. You can of course use whatever information available here to produce an image file that you want. This is a complete personal preference. Moving on to the right side of the settings, you have a meridian flip settings. You can select minutes after meridian, 5 minutes is default, and maximum after meridian is 10, that's also default. Use telescope side appear on, recenter after flip on, that is default, I will keep it. Scope settle time is 30 seconds. Pause before meridian is 0. Autofocus after flip, I would recommend setting that to on. Rotate image after flip, you can set to on by default. This is just for display purposes though. Your actual captured image will be rotated, but that doesn't matter later when you're stacking. They will be rotated according to the reference image that you set. You have some annotate image settings. I will keep it to off, debayer to on, debayered HFR on, linked stretch on. You would probably get some more settings here later when we have installed plugins that we are coming to later. So under advanced settings, stretch factor is default 0.2, backclipping -2.8, star sensitivity is set to high, normal. You can choose to go normal here, and noise reduction I recommend to be none. You can set a default folder for sequence files and sequence template folders, as well as sequencer targets folder. And this is the Windows documents layout. If you want anything else here, you can simply create those folders. I will do so because I want to have this located in my incoming. So here I will create a sequences folder and I will select that. I will do the same for templates here. And select that, and I will do the same for targets here. And select that. This way it's much more easier to copy these files when, or if you are changing your computers for one reason or the other. Collapse sequence templates default off, disable legacy sequencer off. I like to use that for simpler imaging. It's way faster than the advanced, and you can probably get away with most evenings without using the advanced. Before moving on to plate solving, we are going to go into plugins, and I'm going to check on the available plugins, and the ones that I like to have is the Hocus Focus This is an improvement for star detection, star annotation, and autofocus for N.I.N.A. So I really want to install that. I also have the Horizon Creator. Right now I already have created the Horizon, so I really don't need to install this again, but this is a good plugin to have if you are going to create your own custom Horizon. It could also be nice to have a filter offset calculator. I haven't really used it much, but there could be some instances where this is actually good to have, so I'm going to install that. This will require N.I.N.A to do a restart. After the restart, check the plugins tab, and that is correct. We're going to go back to options now and the imaging tab, because there are some settings here that we missed due to the fact that the plugins weren't installed at the moment. And that is the image options, star detector, annotator, and autofocus. And those will be needed to be changed to hocus focus, because I like that better than the original. Now when we have finished this configuration, let's go back to plugins before we forget it and check the plugins that we installed. There's no customization for the filter offset, and there's no customization for the Horizon Creator here. It's just the hocus focus settings. Now here we want to maybe do some configuration. 600 seconds is the autofocus timeout. If you want it to be a little bit bigger, you can select 1200. Validate HFR improvement. I leave it to on default. HFR improvement tolerance. You can set it to 20%. You have a focuser offset of 0 steps. Maximum outlier rejections is 1 point. If you're having some problems here, you could set this to 2 points, but let's keep it at 1 for right now. Rejection confidence 90%. We will let the hyperbolic fit model be default setting of hybrid, the weighted hyperbolic fit to on, and the fit rejection criterion and the rejection threshold at default. There's also some advanced settings for star detection, star annotator, and a camera simulator. But I'm not going to mess with any of these settings right now. I will let them be default, and if necessary, we will return to this when we are exploring the autofocus deeper in a separate video coming. So now we are at plate solving again, going back to options, the last tab, plate solving. I haven't actually installed any plate solving yet, so what we're going to do is we're going to close N.I.N.A. I'm going to open up a browser, and I will browse into the ASTAP website here, hnsky.org/astap.htm, and here you will find a lot of available files. I'm using a Windows 64-bit program, so I'm downloading this one. Just have to wait for the download to start. Looks like it's finished. The setup file. And what I will need also is a star database. So I can choose between all of these types of databases. I will use the D81, and that's a very large star database installer. The only downside is that it is just that, very large, but it will cover everything that you will need. So I would recommend going with that. And if you have a very slow download speed, then you might want to download this somewhere else, put it on a flash drive or something like that, transfer it to your Astro computer. Now when the download is completed, I can close this, open up my downloads folder. Then I will have two install files. So first of all, I'm going to start the ASTEP setup, and it might complain that it is not recognized as a trustworthy source. Just install it anyway. You can choose if you want desktop icons or not, doesn't really matter. When that is completed, you can simply install the star database file. You can see that it is 1.2 gigabytes. So the same procedure with that. Next, and then install. This will take a little bit longer than the original installation, but you have to bear with it and wait for it. When it has completed, click Finish. Then we are going to be opening up N.I.N.A again. Back in N.I.N.A, going back to Options and Plate Solving. We can now choose Plate Solver and Blind Solver, and we will both have them for ASTEP. Next thing you need to do is to point out the ASTEP location on your PC, and that should be the main hard drive, the program files folder, ASTEP, and then the ASTEP executable file. Now we're going to leave search radius, downsample, and maximum objects as default here, but there are some settings up here in the right corner that you can choose, and that is exposure time. 2 seconds might be a little bit too short for narrowband. We're setting this to 6 seconds. You also want to match your default settings for binning and gain. I'm going to be using bin 1 gain 125 as default, but I will have to enter that here. Pointing tolerance, rotation tolerance is set to default. Number of attempts can be set to whatever you would like. It is 10 by default here. And delay between attempts can also be set to whatever you would like, but 2 minutes is the default setting. So now we're done with the plate solving. We will have to, of course, verify that this works later on. Now we're done with the general options here. There are some settings elsewhere in N.I.N.A. Let's go to framing, for example. In framing, you can select the image source, And the default is the HIPS 2 Fits Sky Survey. You can select anyone you want. We will let it be default for now. And you can set some camera parameters. And this is important if you want the correct appearance in the screen to the right here. So I'm going to put in my 6252 by 4176 for my sensor. I have 3.76 nanometers and 509 millimeter focal length. This should be taken from the settings that you entered earlier when it comes to your telescope, camera, and mount. If you want, you can also configure the flat wizard. Right now, I currently own the Flatmaster 150. I'm thinking about doing an upgrade for this season upcoming. I've been looking at the Flatmaster Neo 120 as one option to get it fully automated. When I know that one, I can configure the settings in here. But I actually want the dynamic brightness as the wizard mode default, because I always want to have the same exposure times. We can set 40 as the default settings for flats and darks, because that's what I want. And you can select a target name here. And that will be entered into the file name when you're taking exposures with a flat wizard. That could be helpful. Right now, I only have single mode here, and that's because I don't have any filters configured yet in N.I.N.A. When I do, I will have a multi-mode tab here, and I could select the settings here for each filter. Normally, you would have to have a longer exposure for narrowband filters than for broadband filters, and that is when it is useful. I will return to this subject when I know which flat panel product I will be using for the upcoming season. If we want to double check that the custom horizon works, you can go over to the sequencer, you add a new target, and right now nothing is visible here, and that's because we don't have a target yet. So I'm going to put in whatever here just to get something on the screen here. And now you can see that I can see my custom horizon here. This is the observatory roof. I can also choose to select to see the moon or not. Now, of course, this is not a genuine target. It is just something I made up now, but it doesn't really matter. The important thing is that the custom horizon is visible here on my screen. And that is what we wanted to achieve. This was the basic configuration of N.I.N.A, layout, file name, plugins, and general options, as well as plate solving. We will move on to individual equipment configuration later, as they are connected to the Astro PC. It's time to take a look at some individual equipment settings here in N.I.N.A. Some of the areas I will be covering deeper in separate videos, and that is autofocus and guiding guide camera, as well as flat panel and flat wizard. In N.I.N.A, we're starting on the equipment tab all the way up to the left, and we are going to work our way through the list of equipment here, starting with the camera. Now, I already have the drivers, but this is actually the first time I'm connecting to any of the equipment here, except for the power box switch, which I already connected earlier to this PC in doing another video. In the drop-down menu where it says no camera right now, I'm going to select the Player One Poseidon M Pro. Here I have the native Windows drivers installed. And then I can click connect to this camera, and as you can see here, it connected without any problems. In the information window up here, you can see some basic information about the camera, and then you have some settings, and we are going to change the default gain here to 125 and the default offset to 25. This is going to be the standard settings for this camera. This camera has a built-in dew heater, and you turn that on and off up in the right corner. You can adjust the dew heater strength and fan speed. Maybe I will put the dew heater to 20 as default, and the fan speed I will keep at 70. I've never actually had any problems whatsoever with dew there on the camera. It's not very humid in winter in Sweden at 63 degrees north. You might have another kind of situation if you live elsewhere. The other settings you have in the top right corner is that you can control the cooling. You can set a target temperature, you can press cool button, and you can press the warm button. You can of course also control this through sequences if you want the camera sensor to cool and warm before and after your imaging session. I'm not going to cool the camera right now because we are indoors. You can see that the sensor temperature is 22.5 degrees Celsius here. But we will get into details later on when this is mounted outside in the observatory. Moving on to the filter wheel, and we are going to look at what is available in the drop-down menu, and you can see that we have the Player One Phoenix wheel. I'm going to select that and click connect. Now the filter wheel is connected here. You can see that we have the Phoenix wheel and that we have the driver version 1. What you want to do now is to assign a filter name to each slot. Unfortunately, you can't do that in here. So we are going to go into the Options tab and then Equipment, and here we have the filter wheel. You saw this earlier, but at that time we didn't actually have the filter wheel connected, so you can select a position here and then you can double click on the name and you can assign a different name, and I actually have my filters LRGB to start with. You have to click a few times. And then after my broadband filters, I have S2, and I have HA and O3. LRGB S2HA03. Make sure that you get this right, because if not, and you are programming a sequence with filters, you might get the wrong filter, and you don't want to get that. It will ruin a day or imaging night, so to speak. Going back to equipment and filter wheel, you can see that our changes has gone through. Instead of the slot names, you have LRGB, S2HA, and O3. Now it doesn't say which slot here now, but the first slot is the one on top, and then we are going down. And if you want, you can test to see that the filter wheel is working by changing a slot here. It will work a little bit, and when it's done, it's going to highlight this option again. And you can also see in the status window to the right here that we have the blue filter. If I go back to luminance again, it will work a little bit and then display the luminance filter. Now it's going to take a little bit longer to go back in filters because it always spins the same way. At least the Phoenix wheel operates in that manner. So if you want to go from red to luminance, it's going to have to rotate almost an entire rotation in the filter wheel, but it doesn't take that long. But just know it's nothing wrong with it, it just takes a little bit longer. Moving on to the focuser, we are going to do the same here. We're going to select the focuser, and here we have ZWO Optical EAF, and I'm going to click Connect. Now this is also a piece of equipment that I already configured a little bit because, like I said, there's going to be a separate video on autofocus and how to dial in your maximum steps and your step count and all of this for focus. In my case, if you compare to the old EvoStar 80 ED Pro and the SQA106, the focus tube actually hardly move at all. You have 30 millimeters of maximum focus tube movement, and that translates to roughly 8,000 focuser steps here. So if you have the SQA106, make sure not to have the maximum step size set too high. You can check this by moving to what you believe is maximum and then see how long it can move before it actually stops. Now there is some internal security setting in the focuser. It will beep when it hits an obstacle, but it's not good to do that all the time. So I would recommend checking where the maximum step is and going to 300 steps back. So I think the maximum was like 8,250 or something like that. But you also have to consider using the overshoot function for focusing. So it always goes a little bit beyond what you tell it to. So keep that in mind when setting the maximum step size here. Other than that, not much to configure. If you have your focuser on a side not normally used, maybe you need to activate the reverse setting. I would also recommend going into the absolute 0 and then out just a little bit, and then use set current position to 0. That will be helpful. Also not to just go to the absolute limit and let the motor beep. That is, in my opinion, a bit unnecessary. Moving on through the list here, I don't have a rotator, so there's nothing to configure here. You can of course say that you have a manual rotator and then connect that, because we do have a manual rotator on this telescope. So I could use that, and N.I.N.A will prompt me to manually rotate, and then it will take pictures to verify the position. That will require me to physically go out into the observatory to actually rotate. Mount. Well, I'm currently waiting for my MLastro 1 mount, so I will get back to this in a separate video. There's going to be an option to choose here, the on-step telescope, but for now I'm not going to be configuring the mount. We're going to skip that. Next thing is guiding. We are going to configure PHD2 separately before we go into N.I.N.A settings. So I'm skipping that for now. We're taking it last. The switch. This is the SVBONY SV241 Pro switch. And I'm going to connect this now. I've already connected this earlier because I was testing it. There's going to be a separate video on it, so I won't go through this in too much detail here. It will retain the settings at power loss. If you cut power to this, which is really good, I don't think it did that in earlier firmwares. But for me, I have already assigned two switches here. I have the DC1 and DC2. I'm going to use the camera in DC1, and as you saw earlier, the camera actually has power already. And I'm going to have a separate DO controller on DC2. And right now I'm not using DC3, 4, 5 and the always on DC. I'm going to be using almost all of the USB, so the two USB groups are going to be configured to on. And I'm not going to use the power management RCA outputs or the configurable DC output. But if you do use them, you can make settings here for them. I don't have a flat panel connected right now. I have a Flatmaster 150 out in the observatory. I haven't decided yet if I'm going to be modifying that to work with this equipment. At the distance it is mounted today, it's not going to work with the SQA 106 because the aperture it is much larger than the EvoStar 80 ED Pro. So I'm going to have to do something if I'm keeping it. I definitely don't want to go out into the observatory to take flats. So it's going to be mounted in a different way, or I'm going to go with another flat panel. So flat panel configuration we will also get back to in a separate video. I don't have any weather source or weather apps at the moment. Maybe I will get into a separate video on how to integrate weather connections into N.I.N.A. I also don't have any dome control that is integrated with N.I.N.A. I'm using my Homey home automation system right now, and that's why there's nothing configured here. I open and close my observatory roll-off roof with the Homey Pro and Z-wave relays. There's also no safety monitor. I manually have to verify. To do that, I have cameras in the observatory, and before I open and close the roll-off roof, I can observe the cameras to see that everything is in position so I don't destroy any equipment. The gate motor that I use is very powerful. if the telescope were to be positioned in a way that will interfere with it, it won't stop. So that means the telescope would actually be destroyed if I used it. That was the equipment, or the equipment that we could do at the moment. I'm going to be disconnecting all devices now and make sure that they are disconnected. And then I'm closing N.I.N.A. We're going to continue on with PhD2 configuration. This could be a little bit daunting for most people, but you are greeted with the first light wizard the first time you start PhD2 guiding. And this is the first time I started it on this PC, so we are going to go through the settings here. So right now I have a choice of cameras. If I select player 1 camera, you can see that it will actually choose my main camera here. That looks correct, 3.76 in the pixel size. So I will go down and choose the first ASCOM driver camera from player 1, and that looks good. You can see that we have the correct camera. The pixel size is correct here, 2.9. You can choose a binning level here. For me, I'm not going to touch the default binning 1, but what is really important here is to set the correct focal length for the guide scope, and I have the EvoGuide 50 ED, and that has a focal length of 242 millimeters. So I'm going to set that, and then I will click next. As for the mount, I don't have it connected yet because I don't have the mount. I will select the on-step ASCOM, and then PhD2 won't be able to determine the mount guide speed, but we can configure that later, so we don't really have to worry about it right now. You can select if you have any adaptive optics, which I don't. You can select a rotator, but we don't have a rotator, so I will keep that to none. And then you can enter a profile name for this, and EvoGuide 50 ED and N.I.N.A 585M. You can build a dark frame library for it, and you can also choose to auto restore calibration if you want. Of course, it's best to calibrate every time, but you can set that for now, and that will be the default option, and then you can choose to recalibrate if you want before each session. Then you simply have to click finish. And we get some problems because we are not connected to the mount, and that's fine. So we're going to close that. You can build a dark library. I would suggest doing this, and I don't know now what I will be using in terms of exposure times, but since the MLastro 1 is a harmonic drive, I might want to use very fast exposure times, so I'm going to select 0.2 as my minimum exposure, and the maximum is going to be 4 seconds. I will take 10 frames for each exposure time, and then I will I accidentally clicked reset there now, so maybe I will take this to 5, and then I will click start. Now you have to cover your guide scope. It is covered, so that's okay. Now it is building the dark library here, starting with the fastest speed, then going up into the list, and it will run through all of the settings here. Now the dark library has completed. It might have been a bit excessive to go all the way up to 5 seconds. That's never going to be used, but it doesn't take up that much space. Just make sure that you have fast enough speeds if you have a harmonic drive mount. Now the initial configuration has been done. You can click on the brain for advanced settings, and we are quickly going to go through the start settings here. And keep in mind, this is not going to be in depth here because I don't have the mount and we can't test anything. So that will be a later video where we are dialing in the guiding here. Some basic configuration, global settings for language, software updates, file locations for guide logs and debug logs, if you want to have that. If you want to enable diagnostic image logging, you can have that on. And we have dither settings here, and I would recommend to keep that to random at a scale of 1. That is also the default setting here. Going over to camera settings, we have noise reduction. That will be to none. Time-lapse is 0, default setting. I'm not changing anything for the variable exposure delay. I'm going to keep this for now, auto exposure setting. I'm not 100% sure about this value now. It's not an 8-bit camera, it is a 12-bit, it's not a 16-bit, but seems like most ASCOM drivers will pad 12-bit data to 16, making the 65535 value to be the most correct one to use in my case. If you are using a 12-bit camera and the driver does not pad to 16-bit, you should have 4095 if it outputs 12-bit raw data. We will check that later to make sure it is the correct setting. You have some camera specific properties here. Pixel size should be auto sensed by the driver. You can select a disconnect non-responsive camera after seconds. Keep it to 15, I would say. Binning 1. And there's no cooling on this camera, so you don't have to set any cooler configuration here. Next tab is the guiding, and this will have to be dialed in, I would say, later, but I will go through the settings that are recommended by MLastro. So minimum star HFD and maximum star HFD will be 1.5 and 10. I personally will remove beep on lost star. I won't hear it anyway because it is out in the observatory. If I'm doing a remote desktop, it will just be annoying. I will see it anyway. The mass detection, I keep it to default 50, and I have minimum star as an R6. Use multiple stars. That should be on. If it's not on in your installation by default, you will select it. And then keep the auto selection frame downsample to auto. The calibration settings here, 242 is the focal length. calibration step, that will need to be adjusted. Set it to 200 to start with an harmonic mount. Auto restore calibration. Assume deck orthogonal to RA. That will have to be enabled for the MLastro 1 mount. And the use deck compensation is default on. Keep that on. We have some shared parameters. Always scale images on. Fast recenter on. Keep that to on. Reverse deck output after meridian flip. This is another setting that you need to enable for the MLastro mount. So check that also. And keep enable mount guide output and stop guiding when slew to on. So all of the shared parameters should be set to on here. Going into algorithms, we will select the right ascension algorithm, and the one recommended here is the predictive PEC algorithm. And this will also be adjusted later on, but I will set some initial settings here recommended. So we're starting with 100, 100 for predictive weight and reactive weight. Minimum movement 0.2. Periodic length, this will have to be adjusted. I will set it to 430. This might change later, but auto adjust period is recommended to be off in start. And I'm setting the retain model to 0, keeping max RA duration at 2500. As for the declination resist switch, I'm keeping that. Aggressiveness to 100. Minimum move pixels 0.45. And I'm going to deselect and remove fast switch. And I'm not enabling any backlash compensation here, since we don't actually have that. So these are the starting settings here. And it will be covered later. So let's just click OK here for now. And then we are going to go into N.I.N.A and make sure that the settings for PhD to guiding is okay. I'm going to disconnect the camera here and close that. And then I will close PhD 2 and I will open N.I.N.A here. Once I am here in N.I.N.A, I will go into equipment in the top left corner again, and I will go down to guider. And here I'm going to select PhD 2 and I will have to click configure, and I will browse for the PhD 2. It should locate this automatically, so you actually don't have to change this setting. You can configure some options here regarding dithering, and the default dither pixels is 5. You don't want to enable dither in RA only. We are going to keep the settle pixel tolerance, maximum settle time, and timeout, guiding start timeout, and ROE percentage to find star. So the thing that you might want to consider adjusting here is the dither pixels. It's default 5. I'm going to keep that at default right now, and then I'm going to connect PhD 2 and make sure that it is starting. As expected, it can't connect to the mount, but that is okay. We will actually check that later because there is no mount, so everything is fine. You might want to dial in your dithering settings here in N.I.N.A. This used to be hard because the rule of thumb is you want a dither pixel setting here that will effectively move the telescope 10 pixels in the main camera image. This is important. Don't mix it up with the guide camera image. And you had to manually calculate this back and forth. But right now in the N.I.N.A version that I have, the latest, this information is already available and it will dynamically change it when you are changing settings here. So you can see your guider pixel scale here is 2.47 arc seconds per pixels. Your guider dither pixels is 5, and this is the setting you have up here. Your camera pixel scale is 1.52 arc second per pixel, and your camera dither pixels will move it 8.11. Now the rule of thumb, as I said, is you want this value to be 10 or around 10. And the setting that you have here is multiplied by the default dither pixel setting that you have in PhD2. If you remember, that was 1 by default, and I recommend having that to 1 and change all settings in here, otherwise it will be a bit annoying. So if the goal is to get 10 pixels here on the main camera, we can change this to 4 and see what happens. Then it will go down, and we can change it to 6 and it will go up. So if we change it to 7, it's 11.36. Maybe we will keep it at 6 pixels here, and that will mean that I almost have the 10 pixels of camera dither pixels that I need. So I think I'm going with a dither pixel setting of 6. If you want, you can change the guide graph RA and deck colors. I would keep them right now. I'm not changing anything here. You can change the scale of this if you want it to be a little more suitable for your needs. I wouldn't change any other setting here, leave them at default. And that actually wraps up the PhD2 in N.I.N.A settings. When you go into N.I.N.A every night or when you're going to be imaging, you don't have to select every single accessory or piece of gear manually. You can simply use the Connect All button, and then it will connect all of the equipment that you have configured. And then you might need to go into some equipment and change settings, or for example enable the camera cooling if you don't have that in your sequencer. There's going to be a deeper dive into certain areas, so stay tuned to the channel for that. The bat and the squid speak in their own light. All you need to do is listen long enough. But to listen, you need to be out there, night after night. And that's what the MiniPC gives you, regardless of if you have it in an observatory or not. Consistency. If you're building your own remote observatory and have questions, don't hesitate to drop a comment and I will get back to you. This community is why I make these videos, and I read and answer every comment. Thank you so much for watching this video. If you found it useful, please give it a thumbs up and consider subscribing if you're not already doing so. Until the next video, I wish you have clear skies.